Okay, this video is going to cover analysis of first-order systems in the time domain. So let's start with our typical first-order system. X dot is equal to negative a times x plus b times u. So what is the eigenvalue for this system? Well, we can take the determinant of lambda I minus a, figure out that that is just lambda plus a is equal to 0, setting that determinant equal to 0, and we find out that our eigenvalue lambda is equal to negative a. So the solution for this system is x is equal to our initial condition of x of 0, times e to the negative at, or e lambda t, same thing. So what happens here for different cases of a, or lambda? So if a is very, very big, which means that we have e to the negative of a very big number, we're going to get this black curve here. As opposed to the red, a is going to be very small in magnitude, which means we have a very small, like negative 0.01, 0.001 for our eigenvalue there. So what's going on here? As the eigenvalue's magnitude decreases, it takes longer for x to reach its steady state value, to approach 0 in this case. So let's use another term to describe that, and that is the time constant. So the time constant for a first order linear stable system is tau is equal to negative 1 over lambda, our eigenvalue. The time constant tells you how long it takes for x, in this case, to decay to 37% of its original value for free response. If we have 4 tau, that's a decay to about 2%, so that's roughly steady state. So this 4 tau, that essentially is telling us how long it takes for our system to die out, our time constant times 4. So let's look at some rules for time constants. So if we have 4 times our time constant for a first order linear system, that 4 times time constant is the time it takes for either to get to 98% of the way towards a steady state value with u is equal to 0 and some initial condition, or it can mean to get to 98% of the way towards a steady state value for a step input and 0 initial conditions. Or it could be to get to 98% of the way between some initial condition value and the steady state value for a step input. And that's what that 4 times tau can represent. And that covers analysis of first order systems in the time domain.